Alright, class. Welcome to 6-7 today. Start off with a little shout out to Cadence. This is going to be a fun lesson because I gave a shout out, apparently. It makes it cool. And I'm home right now with my kids. You might hear him coughing in the background every now and then. Here we go. Let's get started. Corresponding parts of similar triangles. Let's write down what we need to know here. Highlighted words. What is a similar figure? Figure that has the same shape, but not necessarily the same size. So one figure is going to be bigger or smaller than the other one, depending on how you look at it. And look at the end of this statement. Make sure we write this down. This is the notation for similar. So this is saying figure ABCD. So ABCD here is similar. That means similar to EFGH. And now if it's similar, then it has the corresponding parts that match up. So if you look here, A looks the same as E. So those are corresponding parts. B matches up with F, C matches up with G, and D matches up with H. So those are the corresponding parts. So if I click here, the corresponding parts, the angles are A to E, B to F, C to G, D to H, and the sides that match up, sides AB and EF match up, BC and FG, and so on and so forth. So those are corresponding parts, because in our eyes they match up when we line them up. The one thing we know about similar triangles, or similar figures in particular, are corresponding angles are congruent. So whenever you see these little loops in the corner, that means they're congruent. So the one loop matches up with the one loop, 2 and 2, 3 and 3. So if they're similar, the angles are congruent, which we don't deal with that very often. They're going to tell you they're congruent. But what we care about most are the sides are proportional, which is what we've been dealing with all chapter. So if these two figures are similar, then AB divided by XY is going to have the exact same ratio, or be proportional to BC divided by YZ, and also AZ divided by XZ. So if we're missing one of these side lengths, we can use proportions to find out what the missing side length is by setting up a proportion, cross-multiplying, and solving. So let's see what that looks like here. We don't have a lot to do today. Quick examples. Here's two similar triangles.
Thank you. Goodbye.
ABC is similar to DEF. Braden says thank you and goodbye. They're similar, the angles are congruent, and they tell us they're similar, so we can write proportions to solve for the missing side. So let's go ahead and do that. So I asked myself, what sides correspond? Well, in my eyes, it looks to me that the 4 matches up with the 12. And normally, I put the small triangle over the large triangle, or the small figure over the large figure. That's just what I do. It works the other way, but I just like to stay consistent. So let's do that. The small triangle, this 4 matches up with the 12. And that's going to equal any other sides that correspond. Well, AB corresponds to ED, but I don't have any numbers there, so I don't need that one. BC matches up with EF. Well, that means 6 matches up with X. So 6 matches up with X. And I have to put the 6 on top because I put the 4 on top of the 12, so I went small triangle over large triangle. I have to stay consistent, so small triangle over large triangle. If you flip them, you're not going to get the correct answer. So let's cross multiply here. I do 6 times 12 is 72. Oh, just awesome writing at home here. Fix that. 72 equals 4 times X is 4X. So then I divide both sides by 4, just solving an equation. Again, those of you that are struggling to show work, this is the work I should see. Alright, then I do 72 divided by 4, and I get an answer of 18 centimeters. That's how long EF is, 18 centimeters. So 4 divided by 12 is the same as 6 divided by 18. Alright, let's do another one here. We have parallelograms now, it looks like, which is no big deal, because all I have to do really is still match up the corresponding sides. So they tell us right here the sides that correspond, but I just like to practice. Let's just ignore that for now. In my eyes, which ones do I see match up? Well, I might have to rotate this around, but if I know a parallelogram, these sides are going to be the same, and these sides are the same, the ones that are across from each other. So let's just mix it up here. Let's do the large one on top just to show you it works both ways. So this 28 matches up with what? Well, the 4 over here. Those are the short sides. So I'm going to put the large figure on top this time. 28 over 4. And that's going to match up with, well, the 49 is the larger side. Matched up with the D, I don't know. And again, I have to put the 49 on top because this time I chose to put the large figure on top. So large over small equals large over small. Sorry, that should be a D. Erase, undo. 49 over D. Alright, now it's just cross multiplying and again dividing. So 4 times 49, I believe, is 146. No, 196. Mental math is a struggle for me today at home. 196 equals 28D. When I cross multiply there. And voila, I divide by 28 on both sides. And I'm just guessing that it will be 7. So this side is 7 feet, which means, 28 divided by 4 is the same as 49 divided by 7, which is true. Alright, let's wrap this up with our real world problem, last problem of the video. We have a decorative window, it looks like here. Someone's trying to make and figure out the distance this missing side DF has to be. And he wants them to be similar triangles. So let's look at this triangle down here first. We pulled it out over here. 18, 18, 25 and a half. And now we have this small triangle. We want it to be proportional. Okay? So, let me grab my pen here. Okay? And let me drag this down a little bit. So, here is my big triangle. I want the small triangle to be similar. So what do the sides have to be for the small triangle? So let me draw this one on the side too here a little bit. And this is going to be 9 up here, right? Okay. Well, this is what I want to find out. Okay, this is DF. DF. And this is E over here. F. Everyone can see this in F, right? Perfect. Moving on. What sides match up, I asked myself. Well, 9 matches up with what? Well, it's not lined up, but if I spin this triangle around, this 9 is going to match up with the 18. So I have 9 over 18 equals, this X matches up with what? Well, again, I spin it around, it's going to match up with the 25 and a half. And so I did small over big, so the X has to go on top of 25 and a half. Now let's do this one mentally instead of cross multiplying necessarily. But again, I showed my work because I set up a proportion. I showed what was equal, so this is what I would need to see. What proportion is 9 over 18? Well, that's half. 9 is half of 18. So what's half of 25.5? Well, maybe if you don't know off the head, but if you divide by 2, that's the same as taking half. So half of 25.5 is, I believe, 12.75. There's Braden coughing again. Let's see if I'm right. Oh, boom. Correct answer. Game over.
Yeah.
I win. That's the end of the lesson. Hope you learned something. Braden, say bye.
Bye.
Have a wonderful day.